Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of integration by substitution with examples. For this lecture, I am using the work of one of my best students, Miss Sayyida Fiza of class 2020, the Lyceum. An important advice for me and for everyone. We must avoid backbiting. Integration by substitution. This method is used when a simple substitution can be applied that can transform a difficult integral into an easier integral. So this is the purpose of using integration by substitution. Through this method, we transform a difficult integral into an easier integral. The integral must be completely rewritten in terms of the new variable. There are two types of integration, definite integration and indefinite. Number one, definite integrals. Well, when using integration by substitution for definite integrals, we substitute two things. Number one, the function, for example x, and number two, integral operator, for example dx. This x and this 6 minus x is the function, and this dx is the integral operator. We change the limits of the integral as well. So we do three things for definite integrals in integration by substitution. We substitute the function, we substitute the integral operator, and we change the limits. Fortunately, the substitution of the function will be given in P3 syllabus. You don't need to suppose function yourself or substitution yourself. This will always be given in the P3 syllabus. To understand integration by substitution for definite integrals, we do this example. Now this is the question. This is the integral I, and use this substitution and show this integral. See, I told you the substitution will always be given. Now, to transform this into this form with the help of this substitution, we have to do three things. Step 1, write this given substitution into a box. Just ignore these two steps. I will explain these two things later. Step number 2, work for dx, because we will substitute dx as well. For dx, always differentiate the given substitution. So by differentiating this with respect to x, we have this thing. You all know how to differentiate under root. See, the differential of this is 1 upon 2 under root 6 minus x times minus 1. This is here. Now substitute this thing by u, because this is u, and make this dx the subject. For that you need to bring this thing on left hand side and this thing on right hand side. So shift this over here and bring this here. So we have dx. The next thing is change the limits. See, when x, and for limits always use given substitution. Make sure you use the given substitution, which is under root 6 minus x. So when x was 2, then u is 2. When you will substitute 2 here, you will get u2. And when x was 5, then u is 1. So we have got the new limits. Now copy the function. This is the question. Always copy the question before substitution. Now substitute everything into this very carefully. Now first change the limits. See, when x was 2, then u is 2. So write 2 here. And when x was 5, then u is 1. So write 1 here. Write the corresponding values of the limits. The corresponding value of this 2 is 2. And the corresponding value of 5 is 1. Copy this 5 here and substitute dx. This is dx. Minus 2u du. So it should be here. Now substitute this by u. And for x, you have to make x subject from this substitution. So by making x subject from this substitution, we have x is equal to 6 minus u square. Sometimes you have to make x subject. It depends on the question. If the question is difficult, then you have to readjust this given substitution. So x is 6 minus u square. So x is 6 minus u square, and this under root 6 minus x is u. So we have substituted everything into this integral. Now we just need to simplify this. See, when lower limit is greater than the upper limit, then we always switch the limits by writing negative sign outside the integral. This is here. When lower limit is greater than the upper limit, then always switch the limits by writing negative sign outside the integral. So this negative is because of the switching of the limits. Now simplify this and break the middle term of this. Now this minus and this minus will become plus, and the factorized form of this is here. And this is what we had to show. So in integration by substitution, we substitute for definite integrals, we substitute function, that is x, and substitution will always be given in P3 syllabus, and we substitute the integral operator, and for that we always differentiate given substitution. Like here, we differentiated this and we got dx, and then change the limits. And for this, for limits, always use given substitution. This is the given substitution. When x was 2, u is 2. When x was 5, then u is 1. Make sure you write the corresponding values of the limits here. And I told you, when lower limit is greater than the upper limit, then always switch the limits by writing negative sign outside the integral. And then simplify this. This is the way to do integration by substitution for definite integrals. One more example to understand this concept well. Use this substitution to show this integral to this integral. This question is relatively easy as compared to the previous question. Now substitution is given. This is step number 1. Number 2, for dx, differentiate this given substitution. When you will differentiate this, you will get this thing. Dx upon d theta, and the differential of tan is sec square theta. So dx is this. Now for limits, use this given substitution. See, when x was 0, according to this substitution, theta is pi by 4. Use the given substitution, which is 2 tan theta is equal to x. See, when x was 2, then theta is pi by 4. And when x was 0, then theta is 0. Now make sure you first copy the question here and then substitute everything into this question very carefully. So when x was 0, theta is 0, it's here. When x was 2, then theta is pi by 4, it's here. Copy this 8 here. Now substitute this x square. So x is 2 tan theta. So 2 tan theta square. And dx is this 2 sec square theta d theta. Now we just need to simplify this carefully. Limits are fine, so just leave the integral as it is. This equal should be here. Well, this will become 16 sec square theta. See, the simplification of this is here. This will become 4 tan square theta, and when you will take 4 common from these two, you'll get 1 plus tan square theta in the bracket, and this is sec square theta, and this square is here. So the simplified form of this is 4 sec square theta, and this square is here. When you will square this, you'll get 16 sec power 4 theta, and when you will cancel this with this, you will get 1 upon sec square theta, and this is cos square theta, and this is what we had to show. We had to show this thing, and we have got this result here. Now to integrate this, use double angle formula. This is the next part. So the double angle formula of cos square theta is 1 plus cos 2 theta upon 2. And the integral of 1 is theta, and the integral of cos 2 theta is sin 2 theta upon 2, and this 2 is here. Now apply the limits here. This is the exact answer. You can check the solution again. This is what we had to show. The second type of indefinite integrals. The first one was definite integral, and this is for indefinite integrals. Well, for indefinite integrals, make sure you rewrite the function in terms of the original variable, like in terms of x. This is a different step with respect to integration by substitution for definite integrals. We do two things here. We substitute the function. We substitute the function and we substitute the integral operator. But at the end, we rewrite the function in terms of the original variable. So the question is, use this substitution, find the answer of this integral. This is indefinite integration. So two things are same. The given substitution is here, and by differentiating this u with respect to x, we have 2 here, and this is the value of dx. Make sure you always differentiate the given substitution for dx. Now substitute everything like this u and this dx into given question. First copy the question. So 4 is here, and this will become u. In fact, this will become under root u, because 2x plus 1 is u. So this is under u, and for this x, just make this x subject from this given substitution. So this x is u minus 1 upon 2, and this is under root u, and the value of dx is du upon 2. So make sure you substitute function and dx carefully. Now after the substitution, you just need to simplify this equation. When you will simplify this, you will get this thing. Now this is very simple to integrate. Just add 1 in power and divide function by the resultant power, and the integral of this is here. Right, see, since this integration is indefinite, so must rewrite your answer in terms of x, in terms of original variable, which is x in this case. So substitute u here and here, and the value of u is 2x plus 1. So this is a different step with respect to integration by substitution for definite integrals. Of course, we don't need to use limits here. We don't need to change the limit because this integration is indefinite. So this is the way to solve the questions for indefinite integrals. Just remember this step. Rewrite the function in terms of the original variable, which is here. I hope this lecture will help you to understand the concepts of integration by substitution for both definite integrals and indefinite integrals well. I am extremely thankful to Ms. Fiza who helped me to make this lecture. May Allah Pak bless her always. Ameen. Good luck to everyone. Allah Hafiz.